Hey guys, welcome to another tutorial. This is your math exam coach, and today we have a tutorial that is on matrices. We are going to talk about enlargement, and we're also going to talk about singular matrix and what that means. So if you're new to this channel, please make sure that you subscribe to the channel, hit the notification button so that you get more notifications when we have new tutorials. I also wanted to let you know we have a new WhatsApp channel that you can be a part of. So I'll put the WhatsApp channel in the comments. Make sure you follow that link and you'll be able to join a WhatsApp group with other students who are going through these different tutorials, and you get to ask any questions that you might have, and we can correspond to those. All right, so let's dive into this question. And by the way, feel free to stop this video if you want to solve the question on your own, and then you hit press and come back again. All right, so the first question here says, if matrix was given 30, 0, 0, 15 over 4x represents an enlargement with the origin as center, find the value of x. All right, so we want to find the value of x. But before we do that, we want to understand what does an enlargement mean, right? So if you're going to have an enlargement, we're thinking it's going to be of the form A, 0, 0, A. This allows us to be able to enlarge in equal directions for the new matrix, or for the new position that we can get. All right. So how does this information help us? So we do know that if the enlargement is from the origin, these diagonals are going to be the same. So here the value of A and A, this was with the origin as the center. So these are going to be equal. So what does that tell us? So that tells us that 30 is equals to 15 over 4x. So now we can easily solve for x here. So therefore, x is going to be equals to 4 by 30 over 15. We know what this is. This is 2, so x equals to 8. So that was a nice one, easy to solve. All right. So then let's go to the second question. So we are told that the matrix y squared 2, 18, 1 is singular, and calculate two possible values of y. All right, so we have, this is the second one. So we have this matrix. It says y squared 2, 18, and 1, and we're told that things that we're told. So we're told that this is singular. What does that mean to be singular? So for a matrix to be singular, it means its determinant of that matrix M is equals to 0. And that just means that that matrix M doesn't have an inverse. All right, so we do know that this matrix doesn't have an inverse. So as you see here, everything in red is just to illustrate and solve the question from a higher level instead of just being interested in this question alone. All right, so we can take a look at a general matrix A, B, C, D. So this is a general matrix, and we say that the determinant of this general matrix has to be 0 for this to be singular, since it doesn't have an inverse. But we also know, so this is matrix M, we also know that the determinant of M for this, in this case, is going to be we're going to take this, multiply this, and then subtract a multiplication of these as well. So our determinant can be written as AD. Our determinant can be written as AD minus BC. But we know that our determinant is going to be 0 since this is singular. Alright, so let's now go back to our matrix y squared, 2, 18, and 1. Alright, so what we can do here is we can get the determinant, which is going to be AD minus BC. So it's going to be y squared multiplied by 1 minus 2 multiplied by 18. So this is going to be y squared minus 36. But we know that this matrix is singular, so this is going to be equals to 0. Right. So we have the determinant as y squared minus 36 is equals to 0. So we want to solve for y. But before we do that, we have seen these square functions, or the perfect square functions, which is a squared minus b squared. We know that we can rewrite this because we want to find the multiple of, remember, in order to get the factors of a quadratic, we want to find AC, the product of AC, such that the difference of this is also going to be 0 in this case, because we don't have a factor of a first order factorial. So we do know that we can rewrite this as a plus b, a minus b equals to 0. Right, so because if we expand this, it's going to be a squared plus ba minus ba minus b squared equals to 0. So this will cancel out, and you have a squared minus b squared is equals to 0. So we know that we can rewrite this as this in this form. So in this case, we know that just like in this case where a squared and b squared are perfect squares, y squared is a perfect square, and 36 is a perfect square of 6. So that means we can rewrite this as y plus 6, y minus 6 is equals to 0. Therefore, y is going to be equal to plus or minus 6. Let's go back here. Calculate the two possible values of y. So we have y equals to plus or minus 6, and here x equals to 8. So that's how we solve for this question. If you enjoyed this tutorial, make sure you subscribe, make sure you like, make sure you share this video, and don't forget to join that WhatsApp channel. Until next time, goodbye for now.